Thank you very much for joining this session. Today we have Mr. Lee Eggleston with us. He's gonna talk us through machine learning with cartoon characters and Christmas tree. This is gonna be a very exciting talk. Again, this is the first talk that we do with this group this year, so hopefully it's gonna be a great start for the year, and we're gonna be kicking it off with Mr. Lee. So please take it from here.
Cheers, Mo, and thanks everyone that's come in. Bit of an intimate session tonight, but it's all good. This is the first time I've done this talk in this way, so it's great practice for me in any case. So let's kick off. Tonight we're going to be looking at machine learning, and we're going to be exploring, or more accurately, I'm going to be explaining a couple of experiments I've done using machine learning with .NET and taking two very different approaches. And really just using some bit silly use cases, but I've learned a lot from those experiments, so I thought I would just share them with you. So who am I, first of all? My name's Lee Eggleston. I'm Developer Relations Lead over at Avanade. If you've never heard of Avanade, that's not surprising, even though we're 40,000 people across the world. We were formed by Microsoft Accenture some 20 years ago, I think. We're still not heard of very much, but that's where I'm from. I'm also a Microsoft MVP in developer technologies. I've done a few other websites you might be interested in, including Visual Studio Tips and those in that list. And more recently, one called techcommunitycalendar.com. So if you've got time, you might want to check those out. I'm also a published author in augmented reality technology. I've also got a talk on how, if you're a .NET developer, you can get into augmented reality development for your iOS device. But if you're looking for some light bedtime reading, you can go find that on Amazon if you want. So that's me. So I thought I'd talk about my motivation of why I wanted to learn machine learning. Also, just pause really briefly, so I'm not an expert in machine learning. Sorry, I'm not an AI expert or data science expert. I'm just sharing some experiments I've done with machine learning, and hopefully this is a good launching point for you all, if you wanted to experiment with machine learning as well. So the reason I wanted to learn machine learning was a few years ago now. Microsoft was getting into this sort of space, and they launched a couple of websites. One's called dog.net, which sounds silly, but what it allowed you to do was upload an image of a dog, and it would wow you with technology, which was quite amazing back then, and it would guess the breed of that dog that you'd uploaded. And then people started uploading pictures of themselves, and it started saying what dog you must look like. So that was quite funny. And then they did another one called howold.net, and the idea was you uploaded an image of yourself, and then you would marvel at how accurately you would guess your age or an age of someone you uploaded. It always kind of aged me a bit on the older side, so I wasn't its biggest fan, but those kind of sites, I always thought, that's amazing. I'd love to be able to create something like that one day. So I thought, well, I went to, last summer, I went to see, well, what kind of code samples can I find to learn machine learning. So I stumbled across Microsoft's very machine learning framework called ML.NET. And because I'm big on Microsoft Stack, I wanted to use C#. I didn't want to use Python. And for the first use case we'll look at tonight, I wanted to learn how to do it locally. So I didn't want to do it in the cloud. The second use case we're going to look at, where I look at Christmas trees, I do use just the cloud. And then in the first use case, I just use offline. So it's these are the two different approaches we're going to look at. So we're going to be using something called transfer learning. And what that means is we're going to build image classification models based on some pre-existing image classification models. So we're not really doing a lot of hard work. All we're doing is refining these image classification models to suit our purposes. I won't really throw out too much more machine learning jargon today, mainly because I don't know that much. I'm not a machine learning expert. So then when I started looking at getting into this sort of stuff, I stumbled across this code sample on your right here. And what it did was it allowed you to run some C# code, download a code sample, and it would look at grayscale images and be able to tell you which images had cracks in tiles and which one didn't. And it was a perfectly good use case. I just found it a bit boring, and I thought to myself, well, what could I do to make myself learn this? Because if I'm learning something, it's got to be interesting to me. So I thought, well, how can I make this more interesting? So then I thought, well, let's keep it really simple. Let's pick a subject that's really categorizable. And for some reason, my brain went to cartoon characters. Because cartoon characters, generally speaking, you look at cartoon character and you can instinctively know if they're a good cartoon character, a goodie, or a bad, evil cartoon character, a baddie. And I thought, well, wouldn't it be cool if I could train an image classification model by giving it two sets of data, a set of good cartoon characters and a set of bad cartoon characters, and then give it a new image that wasn't in that training data and see if it could say, I think it's a good cartoon character or a bad cartoon character, and see how accurate it was. So that's what I decided to do, and we're going to look at the result of that just now. It did make me go off a bit of a tangent and make me think, well, why does my brain think that these along the bottom are bad and these along the top are good? You know, what is it? Is it the yellow eyes? Is it the dark colors? There must be a reason that my brain thinks the ones at the top are good and the ones at the bottom are bad. So I actually went off on a bit of a tangent and looked at how our brains perceive faces and what's going on there. And it turns out, I've only got this tangent for one slide, so apologies. It turns out our brains have got a dedicated part of it that's all about detecting faces. And it's the reason why we see faces in everyday objects. It's a phenomenon called, I think, pareidolia. I think I'm saying that right. It sounds like a flower in my garden or something. But early man or woman, as we came out of early cave people, it was very important for us to be able to recognize faces in our fellow tribespeople, or is it a stranger, a warring faction tribe that we don't understand? So it was very or we don't recognize. So it was very important for us to be able to discern whether it was friend or foe that's approaching us. I think so. It was key to our survival in early days. But this pareidolia is fascinating. So not only in these inanimate objects can we see faces, we can also sort of discern from them some emotional state. You know, we can see that the mop and the bread and the typewriter look angry, and whereas the coffee looks happy. And they obviously aren't human faces, but our brain is telling us that these are faces. So it was important for survival early on, but these days it's more important because nonverbal communication accounts for up to 70% of human interaction. It's very important when it comes to understanding how someone's feeling and empathy, and it's what we can describe as emotional intelligence or emotional quotient. And it's very important for people like leaders or people who really want to form relationships with a colleague. So the last thing I'll say on this is, early days, it was key to our survival, and these days it's more key to our success. That's why faces are important. And my separate talk does some interesting stuff with analyzing the faces with code. Anyway, back to the main event. Trying to train an image classification model to discern whether a cartoon character is good or bad. So I was going through the steps that I took. So the first thing I did was I needed to source a whole lot of images. So I just Googled good cartoon characters and evil cartoon characters. You might want to turn on the safe search filters because you do get some dodgy stuff. So then I managed to get 70 images of goodies and 70 images of baddies, totaling 140. If your maths is as good as anywhere as good as mine. And I thought, well, that's enough. Surely 140 images, that's enough for me to train my image classification model. Then it's also important to note that you don't use all of your images to train the data. You use the majority of that, but you need to keep some aside that you're going to use as your test data. So you don't want to use your test data in the actual data set that you use to train the data. Otherwise you'll get false positives. So that was step one. And as I was downloading these images, I did kind of stop and think about, hang on a sec. I don't know much about data science, but I'm led to believe that bias is a problem, and that I did think to myself, well, what if I'm choosing more female goodies than baddies? Or what if the red colors I usually download are baddies, or if they're in light colors, I download them because they look good, and they're probably goodies. And I didn't really put too much, I kind of gave myself a hard time. I think, well, maybe I should randomize this. But then I kind of had a word with myself and said, this is just an experiment. This isn't production data. If I do want to productionize this, obviously I need to think a bit more about the data science, but you just got to be aware about bias when it comes to your data. And as they say, garbage in, garbage out. So if you ever do want to productionize a machine learning model, you need to think about bias and stuff like that. Anyway, step 2, I had my 2 sets of images, my goodies, my baddies. I tweaked the C# code sample to use those, ran the code, point out them, and it didn't work. The first gotcha was that the underlying machine learning architecture I was using was something called ResNet. I won't go into too much detail about that. It's just a machine learning architecture which has many layers, which is underpinning and what we're building on top of to customize. And I found that all the images need to be 224 by 224 pixels. So I had to go and resize 140 different images, which took a while because some were all different shapes and sizes. Some were portraits, some were landscape. I had to crop them because I wanted to prioritize the face if I could only get a square cropping of the image. So that took a while. Did all that, ran the code again and again, it didn't work. So I was scratching my head a bit as to why my code wasn't working. Well, the code was working, it just refused to make the model, and the error message wasn't really helpful. So I looked at the actual code sample, and it looked like the tile case study, use case that they had an awful lot of images. So I thought, well, maybe I don't have enough images. So out of desperation, I just selected all my 140 images, or however many I was using to train the data, Control-C, Control-V, and just duplicated them. And it's probably something was very, very, very bad in a data science kind of world. But I thought, right, now I've got 280 images. I realized that I've got 2 of every image, but I ran it again and it worked. So this kind of tells me that there must be some sort of threshold as to the minimum amount of images it needs to produce the model. Again, probably not best practice, but I had a model being created now. So that was the gotcha number 2, that there seems to be some sort of minimal images needed. I don't know what it is, but it's more than 140. So then I had this model, and I ran the next part of the C# code where you actually point at it JPEGs that aren't that you didn't use to train your model. And I was amazed to see that the 3 baddie images that I gave it and the 3 goodie images I gave it, it's determined with 100% accuracy that the 3 bad ones are bad and the 3 good ones were good. You've got Cruella de Vil on the top left, some sort of evil scientist, someone I don't recognize in the middle of there, and then you've got Super Ted, Banana Man, and He-Man. So at this point, I was quite surprised. This was the 6 random test images I picked, the first 6, and it got it with 100% accuracy. And then if you do download the code from GitHub, or you train your own sort of image classification model, and you've never done this before, and you've got this sort of positive result, you're probably being a bit awestruck, because I was, and I thought, this is weird. I've managed to create something that almost shows a type of intelligence. There's obviously this black box. I don't know what's going on under the hood. It's not an algorithm I've programmed. I just give this image model and this code an image, and then it does something magical, and then it says if it's a good or a baddie, and it does it scarily accurate. So I recommend you do that just for that feeling to create something amazing. So now I had this console application which ran locally, and that was great, but not particularly useful. So I just thought I'll create an Azure function for it, so I can host this in Azure, and then I could just send an image to it. let it process it in the Azure function and then send the response back. Is it a good or is it a bad cartoon character? So I created an Azure function with an HTTP trigger. I did the ML model, which ended up being a zip file, which is just apparently what it outputs at the end. It wasn't a small zip file, considering it was only 140 images. This zip file, I think, ended up being 160 or 180 megabytes. Now, I think this is this ResNet that we're building on above. And to be honest, the first time I tried uploading it to the Azure function, it failed. So I don't think Azure functions are used to being used to containing 180 or 160 megabyte zip files. But eventually, I got it uploaded and working, and I could post the images to the Azure function and get the response back. But a couple of other gotchas. You can obviously run these Azure functions locally before you upload it, which you probably want to do. If you do that, you need to add a cause section to the host application setting that says allow it to call it from anything to call it. If you're going to do that locally, any sort of source to the destination. And then when you go and publish it live in Azure, you need to make sure in the cause section to allow the origins that you want the Azure function to accept requests from. I ended up creating the site at goodyorbaddy.com. So I'm saying any requests to the Azure function from goodyorbaddy.com, then allow them through. So a couple more gotchas there. Then once I got my Azure function working, I wanted to create a front-end HTML file to be able to call it. But I didn't want to create a fully blown .NET Core web app with a big server-side code and runtime and stuff like that. All I wanted to do was see if I could create a simple HTML file, host it somewhere. As it happened, I'd never used GitHub Pages before, but I knew that you could host a very simple site on there. So I did that for the first time. That worked great. It turned out you can point your own DNS at your GitHub pages. So if you've not tried that, I recommend trying that. And another hint I would recommend doing, if you have got simple HTML files locally, but you want to run them as you would as a server, and you want to mimic the server-like environment as it would be if you push it onto the server somewhere, you can use a VS Code extension called Live Server. So once you've got that installed and you're looking at your HTML file, there's a button that says Go Live at the bottom of the, not taskbar, but whatever bar is at the bottom of VS Code these days, and it will spin up a local server, and it will save that HTML on that site just as though it would if it was online somewhere. So the site I created, or just a simple HTML file, it uses dropzone.js, and what that does, all it does is it creates a section on the HTML page where you can drag an image onto it and release, and then it will post that image somewhere and then return the response. So it posts it off to the Azure function, looks at the response, and returns the result. Yeah. So then it looks a bit like this. So on the left is just what the dropzone site looks like. It's pretty neat. You can try that. And that's what the site looks like at the right. I'm not a designer, but that's live. So you can go try that at the moment. So you can do a demo in a minute. But this is the eventual architecture that we ended up with for goodyorbaddy.com. The DNS was pointed to GitHub Pages. All that did was host a simple HTML file and used dropzone.js to post the image over to the Azure function, and the Azure function hosted this ML.NET image classification model that I trained using a console application and just uploaded up there. So pretty simple architecture, but again, it was an experiment, throwaway experiment, not meant for production, just for doing stuff like this. And then someone, I demonstrated this to as a brown bag session in my workplace, and they thought it was pretty neat. And then at the questions at the end, someone sort of threw me a bit of a curveball, and they said, well, what about cartoon characters that started off good and that then turned evil? And I kind of paused and caught my breath for a second as I thought, how do I respond to this without upsetting anyone? So the question was, how is my program sentient enough to know the plot behind this cartoon character? And of course, the answer is it's not that clever. How could it possibly be that clever? However, I did humor him, and I don't know if you ever watched Frozen, but there's a bit of a spoiler coming. So if you haven't, maybe close the ends of your ears. But in it, there's a cartoon character that at the beginning appears good, and then it turns out he's evil. And so this same cartoon character, here's an image of him before he was evil and when he was good. And then I uploaded an image of him when he was bad. And again, I didn't use this image for training, don't think, but the goodieorbaddie.com was managed to say at that point in time, he was a goodie, and at this point in time, he was a baddie. So I was quite impressed with the model, but it managed to sort of save me and that awkward question at that point. So that's what the site looks like. And we can look at the code in a minute. But before we do that, I just want you to sort of open your minds as to what other possibilities there are with image classification. You could do anything with this. If you've got a bank of different images, you could get a lot of images of biscuits and then tag them all, and then you could have the image classification model that if you could upload an image of any biscuit and it would tell you the name of it. That'd be pretty neat. I don't know how useful it would be, but it would be a good exercise. And again, with flags, you could have a whole load of images of different flags. It might be difficult because I think there's like 195 different countries flags, but you could train and give it an image of a flag and it would say, yep, that's the British flag, that's the Greek flag, that's the Swiss flag. That'd be quite neat. And this sort of project is great for hackathons and side projects because you don't have to do a whole lot of work to produce something that's quite impressive. But yeah, so that's kind of neat. And then another project that I wanted to do with image classification is What the Duck. And again, humorous play on words, right? But the idea was to upload lots of different images of different species of duck and then upload other images that weren't in the the training data, and see if it could determine the species of duck. So I thought that'd be quite neat, might get RSPB involved. But yeah, so in summary, this is just concluding the first half of the talk. Oh no, we said we'd look at the code, didn't we? So we'll jump and look at the code in a minute. So then, just in summary, if you want to go off and learn machine learning, just give it a go. You don't have to do a massive deep dive. Keep it simple, and then just keep it simple, keep it silly. It doesn't have to be production data. It doesn't have to be a use case that saves the world. Make it fun. That's still how you're going to learn, and then share what you learn. It is important that people come back to these events and then share what they've learned, just like I'm doing. It does help. And yeah, it's at goodieorbaddie.com, and the code is on at GitHub, and you can pull that down and try it today if you want. So I'm going to jump and show you the code at the moment, and really hope that I'm sharing this screen, hopefully, and not just the presentation. So hopefully you can see the code. Hope someone interrupts me or pings in the chat if you can't, but I'm just going to presume you can. So this is this simple HTML file. Oh, that's not the right site. That's the Christmas tree one. Excuse me. This is the right site. This is the one for the GoodieOrBaddie image classification. Now remember, this is all done locally. This isn't using the cloud at all, except to host the function. So the training happens in here. Now I'm going to kind of whiz through this code because I probably can't do it justice explaining what happens, but I'm going to give it a go. Okay, so the first thing you'll do is you'll need to create the model. The model that it creates, I've not uploaded into GitHub. So the first thing you'll have to do is create the model, and it takes 7.5 minutes on my laptop anyway. The reason being that I couldn't save a 180 megabyte file in GitHub for some reason. I tried various different approaches, but creating the model will kind of teach you how it works anyway. So in this create model method here, I'll zoom in my code a bit more, and I'll turn off those dots if you don't like them. So then you want a path to where your training images are. And this ML context class here, this is the magic where the ML.NET happens. And then you're going to get something that holds your images from the directory. This use folder name as label true is important. So that's just saying that if your folder is called goodie and the other one's called baddie, it's going to use that folder name as the label. And the label is kind of what you are saying that you're expecting this to be. So that's how you sort of split up your training data. So that's getting the images, and then this is creating the image data. I'm just going to look at the chat. Oh yeah, I got some. Yeah, I did try and use GLFS. I just couldn't get it working. Perhaps I wasn't patient enough. Then it kind of shuffles the data. Again, this is all helper functions inside this ML context class, which I know quite a little about. Then we're creating a processing pipeline apparently, and what this is doing is mapping, doing some mapping of the labels to the images and the image paths. Again, I'm going to really skip over some of this and just point out the lines of code that I know that's happening, that kind of know what it does. Then it's kind of splitting the data, it's splitting the training data and the testing, internal testing data, the validation data. Again, a lot of this was pulled from the code sample. I didn't write a lot of this. And you've got your training set, your validation set. Then these are your image classification options. This here is kind of important. This is the underlying architecture that machine learning architecture that we're building upon. And I'm using this ResNet v2 101, and I believe the 101 means there's 101 of different layers in this, something that's called a convolutional network. Yeah, it's a lot of machine learning phrases and that I'm unfamiliar with, which I do really need to learn. This callback thing is just outputting to the console during the training, how it's going. This is the training pipeline. This is actually doing the work. This is actually creating the model. And at this point, the model's in memory. And then at this point, we're saving the trained model to the output zip location. And yeah, I did a really poor job of describing that, so my apologies. But that is all you need to do, is to create the model. So then what you can do is take the model you've created and test it against images. So I look at this method here. It's got a path to the model that we've trained. It's got a path to the image that we want it to test. And then this is the label that we think it's going to be. So if I go to this, this is instantiating this ML context. Again, this code is just for testing purposes and demonstration purposes. It probably can be refactored and improved. It's loading the model into memory. It's it's getting the path to the image, getting an array of bytes and storing that. And then it's doing the prediction, and then it's outputting and saying what it predicts. And I'll just run that because it's pretty quick. It's not really quick. When we go on to look at the cloud example next, where I'm discerning Christmas trees and regular trees, I'm surprised how much quicker that is than locally. But that probably speaks more of my code that I've written for this than the actual ML.NET itself. You can ignore this sort of text at the top, I do. So it's saying classifying image using the existing model here. This image called baddie 1 JPEG, the expected value is bad and the predicted value is bad. And it does this for each of those images. So I'm just going to stop that because I showed you earlier that it correctly identified them earlier. So let's jump back to the talk at that point. No, sorry, I beg your pardon. So that's the training. That's the console application. There's some unit tests here in there as well. The Azure function is pretty simple. It's a lot of it's boilerplate, as you know, but it's getting an array of bytes from the uploaded file that we're running. It's getting a path to the machine learning model, and it's instantiating this image classifier class that I created, which sort of abstracts some of that machine learning stuff and does the prediction, and then returns the result there. That image classifier class that we just talked about then, it just does what it was doing in that console application. It's instantiating this ML context, loading the machine learning model and the prediction engine, and then returning the label from based on the array of bytes we're giving it in, which is just the image. So that's the code. That's all the code I wanted to show you. Yeah, that should be enough, really. Again, if you pull this down from GitHub, run it locally, the best way to learn is just try this out, right? So that kind of concludes the first half of how to train an image classification model locally using ML.NET. The next thing I want to show you is how you can do all this online. And I did something over in December that which was quite fun. So I used a website called customvision.ai, uploaded a load of images of Christmas trees and regular trees, far fewer actually this time than 140. And then with a scaling degree of accuracy, it could tell me if an image of a tree uploaded, if it thinks it was a Christmas tree or a not a Christmas tree. So I'm going to run you through the steps that I did on that live. So this is the image class. If you go to customvision.ai and log in, you won't have any projects. You'll just see this new project button. Here's one I created earlier, but I will run through the steps to create the project. So create your project, give it a name. Let's call it is Christmas Tree 2. Why not? You don't need a description. The resource, you could just create a new one, and you just need to make sure you've got a, let me get this right, Azure subscription that you can use. Give it a name, choose a resource group, keep all this as default, choose the location that's probably close to you, and the pricing tier S probably usually stands for standard, right? I've not received a bill for this yet, so I think you get a lot of calls free. Again, this isn't production, so you should be able to play around with this without incurring too much of a cost. So then the project type I use classification. So with classification and not object detection, because we want to classify an image, right? And then I want multi-class. So for each image, I just want a single tag. I don't want multiple tags per image. So I choose multi-class. Then the domains. Now this helps it choose which machine learning architecture and model to use under the hood. Now I use this one, General Compact S1, mainly because it's recommended to me from someone. It also has the benefit of being a compact version, which means once you've trained your model, you can actually download it, and it's a good option to use in like a mobile app because of its size. And then also the export capabilities. I just use the default one, which is basic platform. Here, I don't actually know what Vision AI Dev Kit is, don't need to know. And then you'd create your project. You won't have any images, so you just click Add Images. Then I've got 3 folders here. I've got one of Christmas trees, just 20 images of Christmas trees, and they're all kind of different shapes and sizes, but most of them are traditional Christmas trees. There's, oh, didn't need to do that. Let's close that. There's, if I can zoom in, no, yeah. So there's different kinds, right? So there's some close-ups, there's various different types of Christmas tree. Yeah, so I can say, let's hold them, upload them. It's pretty quick with the upload, I'm quite surprised. So as I'm uploading those 20 images, doesn't look like 20 there. Yeah, it says 20. I just say what label I want to give them, sorry, what tag. So let's just call that Christmas tree. Upload those, super quick. Those 20 images done. Then I want to add my regular trees. And they look like this, not a Christmas tree in sight. I did think it was a good idea to add some like, not pine trees, kind of fir trees, some trees that kind of the shape of a Christmas tree, like this one and this one and this one, but weren't actually a Christmas tree. My definition of Christmas tree for this context of this experiment is also it has to have lights. Okay, so if you strip a Christmas tree of its lights, I'm not counting it, or decorations or tinsel, stuff like that, or baubles. I'm not counting it as a Christmas tree. So that's what I'm calling a Christmas tree. Sorry, let's select all 20. Let's call that regular tree. Regular tree. Upload those. Done. So the next thing you need to do is hit train. And you've got two options here. I've only ever used quick training. I've never done advanced training. I've never seen quick training's always suited me, but then again, I've not really been doing any real world examples. So doing quick training, you hit train, and then that takes about 5 minutes, I think. So then I'm going to jump to my previous model because that's pretty much what it's going to output. So what I created earlier here, once it's finished training, you'll notice I'm using exactly the same image sets, by the way. You get this screen, and this is the performance, and it's saying, based on the images that you've given us, we managed to, and the model that you've chosen, this General Combat S1, we managed to be able to, with 100% accuracy and precision, guess or determine what they are. It is saying down here that we recommend having at least 50 images in each set of data, hence why it's red. But I've got this working with 100% accuracy with 20 images. But so yeah. So then the first thing that you want to do is do quick test. So we do quick test to train your model before you consume it or put anywhere to use. And you can either give it an image to, sorry, a URL to an image online or browse local files. So let's do that. So these aren't, sorry, you shouldn't test the model on the data that you use to produce the model. So let's go to this test folder, and none of these images of trees should be in there. They might, maybe not. Some of these definitely weren't. So let's choose this one. This one definitely wasn't in there. So again, not a traditional Christmas tree. It's quite weird in shape, but it says it's 93.8% sure that's still a Christmas tree. So let's try some other ones. That was definitely wasn't in the training data. 92% sure it's Christmas tree. 8% sure it's a regular tree. And let's try some interesting images. Here's a Christmas tree upside down. So nothing like any of the training data we've given it, but it still says it's 99% sure that's Christmas tree, even though it's upside down. Let's choose some that aren't Christmas trees. So here's a red one. It's saying it's 68% sure it's a regular tree and 93% sure it's a Christmas tree. This is looking good. You can throw it some colorful trees. Yeah, it's 93% sure that's a regular tree, not a Christmas tree. And then I like to throw it some weird ones. So we've got someone wearing a Christmas tree outfit. I would still class that as a Christmas tree. Feel free to disagree, but it's saying it's 56% sure it's a Christmas tree. So it was really on the edge, but it still said it's Christmas tree. You won't want to put your presents under there, but still saying it's Christmas tree. Here's a tree that's very, very dead. Yep, regular tree, not Christmas tree. And then you get some really weird ones like, here's one that's shaped like Godzilla, okay? It's got lights, so I'm still counting that as a Christmas tree. And sure enough, it's saying it's 95% sure it's a Christmas tree. So let's just stop and remember that we only give it 20 images of Christmas trees and 20 images of regular trees. And yet it's still been able to, I've not been able to trip it up yet. So let's carry on with a few more. Here's one that's a Christmas tree wrapped in toilet paper. 96% sure it's still a Christmas tree. Here's, only do a couple more, I'm not going to do them all. Here's a very unusual tree, very messy, not the best decorated tree. 82% sure it's Christmas tree. And then maybe last one, where is it? Cookie Monster tree, there we go. 94% sure it's Christmas tree. So that's kind of cool. So I can say I'm happy with this model. Then the other thing, oh, sorry, something in the chat, let's have a look. What was the second to last? Your Christmas tree, Lee? No, it wasn't. Mine Christmas tree is not on here, but it's a good question. So whatever you upload, it does keep a record of it. And thank God no one has been found this endpoint and gone to his Christmas tree and uploaded some naughty images, because it would be showing here. Please don't do that. So it records any images that's been uploaded. That's kind of neat, and what it predicted. Was it? Go back to this one. So the next thing you need to do once you're happy with the model and it's working online is you need to publish it. It would normally say publish, not unpublish. So you'd hit that, and you'd need to do that because you won't get this prediction URL until you've done that. So once you've published it, it will give you this prediction URL. So what we're going to do now is we're going to use that and prove that we're going to call this endpoint using Postman. Okay, so here is Postman. And in this post, you'll see that it's got that URL here, this very long URL, ends in 7D5 here. Oh, sorry, there's two different endpoints you can hit. One is if you want to give it an image URL, and another if you want to actually give it the file. And it's this bottom one I'm interested in. So that's the one I've given it up here in the post. Post address. Then I need to give it a couple of headers, which it says here. I need to set the prediction header to this key, and I need to set the content type to application octet stream, and I need to set the body to image file. So that's what I've gone and done in Postman. There's my headers, just to prove I'm not lying, and then there's my image, and I will actually upload another image for the purpose of this. Let's give it one that I've not done yet. So let's give it this one, which again is shaped like a Christmas tree, but it's not got any lights on. So I wouldn't call it a Christmas tree. So I would expect that to say it's a regular tree. So let's send that. In fact, I think I did. Oh no. Let's send. Let's see what it comes back with. So here is the JSON response, and these will change in order based on which one it's most confident with at the top. So don't always assume that it's going to be Christmas tree at the top or regular tree at the top. It's still 99% sure that it's a regular tree, even though it's pretty good shape for a Christmas tree. So there we go. We've got an endpoint that's working, that we've trained. So next, I'm going to show you how we can consume that endpoint. And just to show you that is it this one? Just to show you that the model has finished training. You know, it doesn't take hours. It has finished training. There it is. Image is Christmas tree 2. If I wanted, I could plug in some of those values into Fiddler. I'm not going to do that because I don't want to anger the demo gods, but I've got a model that I know that works. So we've done Postman. So then let's look at some code. Do you want to look at the code now? Yeah, let's look at the code. So what is this making? This is, again, simple HTML file. I'm not using drop zone this time, but what I am doing is, if I can find the JavaScript, please don't judge me on the JavaScript code either. Let me run it local. Here's this magic go live button here from this Visual Studio add-in. So this is what it's spinning up locally. And this is the site that's live at the moment. It is christmastree.com. So very, very similar to the goodyourbaddie.com. You know, the design for that was so amazing. Why not repeat it? Again, the link to the code on GitHub is here. And the idea is, I'll get the live one right now because that's not going to work. I don't think the local one, but I choose an image of a Christmas tree. Let's use a test one. Let's use maybe this one I've not used yet. Actually, let's use this one. This is like a plastic Christmas tree. So it'll send that off to the endpoint in custom vision AI. And it's saying, yeah, it's 95% sure it is a Christmas tree. So let's quickly have a look at the code that's going on. You'll also find that's a lot quicker than the other model that I created. So if we completely change tack and just go to the goodyourbaddie.com, sorry for the tangent. If I upload an image here to this site, that's going off to call the Azure Function member from our previous example. It feels a bit slower, but again, that's probably my code not not to the actual machine ml.net. Yeah, that's saying that it's a goodie. So yeah, it's a bit slower, I find, that one. Anyway, we're going to look at the code for its Christmas tree. So, where is my input? So this is the button that says select file. Yeah, so we're saying on change when you call this open file method function with this event parameter. And then in here, what we're doing is that's the file. We're chunking we're getting the file, we're fading a panel, we're chunking that file, getting ready to send it, turning it into an array of bytes here, or a blob, sorry, beg your pardon, what, an array of bytes, and then creating a blob, and then we are doing an AJAX call to that endpoint, same one we called in Postman. I keep wanting to say Fiddler, Postman. Giving it the headers that it needs, and then say the types post, setting what the data is, this image content blob here, and then we are, then it's doing the call, and then on the function that's returned, we're saying send the results to the console, but get me the name of the prediction. And remember, these can come in different orders, so it's either going to be regular tree or Christmas tree, and also get me the probability. Remember, that's like a floating point decimal number, so we times it by 100 to get like a percentage. So we're saying if the probability is greater than 50 and the prediction name was Christmas tree, then show that is Christmas tree panel and fade it in. Else, then it must be the regular tree, fade that in and say what the probability was. Yeah. So that's all that code is doing. Yes, let's jump back though to the presentation, because I think that's everything I wanted to go through. So just to recap, I showed you two different ways of playing around with machine learning, emphasis on the word playing around. How to train your model locally with images locally without using the cloud, and then how to do it in the cloud, solely in the cloud, and hosting it in the cloud as well. So yeah, with that, got a bit quicker than I thought, but yeah, thanks very much. Do follow me on GitHub, Twitter, LinkedIn, and YouTube. I'm at Lee Eggleston and all of those. And then do check out careers.avnerd.com if you're looking for your next role. So I think we'll wrap it up there if that's okay, Mo. And if anyone's got any questions, I'll do my best to answer them. But like I said, not a machine learning expert. I can talk to you about my experiments and the gotchas I found and stuff like that. But please don't throw any difficult data science questions at me, because I just won't be able to answer them. But yeah, anyone's got any questions?
Well, first of all, thank you, Lee. It's a really interesting and really amazing interview, and basically something really open your mind with a simple DLL or simple library that we can install. We can have access to all of this power basically that we just got out of the box. Does anyone have any questions? Well, I have a couple of questions, Lee, if you don't mind.
Yeah, sure.
So you spoke about the bias when you try to train your model. Yeah. So how can we abstract that bias? It's really, because I was thinking about it while you're speaking, and at the end of the day, you're providing the data you're going to be training the model. And at the end of the day, your bias is inside this data that you're actually providing. Do you think there's a way that we can actually abstract that bias?
The only way I could think of at the time, and I didn't follow this through to completion, was just to randomize, just somehow get it to pull down random images using a random counter or something. Just take any sort of manual curation of and manual selection of those images out of the question.
Yeah.
And because even though I think I'm getting a good selection of males and females and goodies and baddies, I won't be. You know, there's so much bias going on in our brain all the time, we're just unaware of it. But randomizing the data is the only way I could think of. But it seemed like quite a lot of effort to try and build that in for something I just wanted to test. Yeah. But now that I've tested the proof of concept, there's nothing from stopping me going back and somehow randomizing that data. But I believe bias is a big problem in data science.
Yeah. Another question also related to the image processing. So basically what we said is you're going to be posting that image to the Azure function. The Azure function is going to take it, send it to the model. That image itself, is it going to be used again to train the model once it's published on the Azure function? Or what do you do with that image after?
So for this purpose, it's not used to refine the model. It's just throwaway. It's here's an input, check it against the existing model. Here's what we found. It's not further refining that model.
Okay.
Yeah.
Okay. And let's say we want to further refine that model after. So basically, what you need to do is you need to retrain it and republish it again to the Azure function. Would that affect the scoring and the bias that happened before? So let's say before that, like let's say for a Christmas tree, it gave it like a 70 a Christmas tree and 30 regular tree. So let's say, for example, after retraining it again, do you think that percentage will change or will shift depending on the new model?
I don't know. It's a really good question. I expect it would. I mean, one example is that when I did the brown bag session to my colleagues, someone said that they uploaded an image of Baby Yoda and Father Christmas to goodyourbaddie.com, and they both came back as baddie. I was like, yeah, okay, it's not going to be 100% accurate. There's nothing stopping me from including images of Father Christmas and Baby Yoda or the Easter Bunny or the Tooth Fairy in that training data, and then refining it if that really is a use case, and doing it that way. So whether that would affect the accuracy or the weightings of the other stuff, I don't know. I would have thought so. I would have thought the more data you have, I would have thought it would change the weightings somehow. But again, I don't know.
Okay, great. Thanks, Lee. And I think we got a very interesting question from Christian, who said, how would the model respond if we were feed it an image both containing both elements, i.e. a regular tree and a Christmas tree?
So it's a good question. For my simple experiment, it would probably just see the Christmas tree and say it's Christmas. Now, what I probably didn't show, because I don't use it in my example, but as you're uploading those sets of image, you can add, what's it called? Something like negators. So you can say, was it detractors? I forget. But there's a way of saying you could say this is a Christmas tree, but if you see this in it, then class it not as a Christmas tree. I forget. But there is a way of refining those data sets. I've not described that very well. I'll see if I can. I've closed it now. If you want to go on to the next question, I'll see if I can find what I was talking about.
So is it like conditional basically on what type of data it's processing? You can refine it if it's good or bad, or if it's a Christmas tree or a regular tree.
It's a way of adding like nuances to the data. So yes, it's in this group of data, but gosh, I can't find it.
So we can let's say modify the metadata, and based on that metadata, we can utilize it.
I'm not sure. I'm going to completely swerve this question.
No worries. No worries.
And just say no comment. I'm not sure. but it would almost certainly pick up the Christmas tree and say it's a Christmas tree. Yeah.
Perfect. And one last question from my side. So you said that Azure Function has a limitation of 150 or something like that. It's not used to it. So let's say we want to make it as a continuous, like I just want to keep training it and updating it. And Azure Function has that limitation. Do you think there's other platform that we can utilize on the Azure platform so we can host these types of applications?
So I don't know if there is officially like a limitation, or if I was just unlucky when I was at FTP with the file, if it failed. It felt like I seem to remember I tried uploading it a few times and it failed. And it was like the third attempt. So it kind of felt wrong. You know, your Azure Functions, it kind of feels like the serverless, they should be relatively small and atomic and minimum. It felt a bit dirty putting almost 200 megabytes up there. But you know, you could, I suppose you could change, instead of having an Azure function, you could move it away from serverless and create an Azure app service, you know, something a bit meatier, and then you can really ramp up the performance on that, kind of, and choose the different performance levels you want.
Perfect, perfect. These are all of my questions. Thank you very much, Lee. Does anyone else have any questions? I take that silence as a no. And again, this is the first session of the year. I would like to thank everyone for attending, and thank you, Lee, very much for taking the time to give us this amazing presentation. Please make sure to follow us on the social platform, and also follow Lee, and stay in contact with us here. And yeah, thank you very much, and hopefully we'll see you next time. Thank you, everyone. Thanks, Steve.
Thanks, everyone. Cheers, Mo.